So my name is Ahmad Syakir bin Fisal. My metric number is CD200020. Today I will talk about chapter 1, the introduction. Mechanical pumps have a wide range of application nowadays. They are commonly used in well water pumping, aquarium filtration, pump filtering, and aeration. Water pumps are mostly used to exchange fluid such as water. The essential function concept of a water pump is based on the positive displacement principle and kinetic energy which help propel the water. Solar pumps are a green, easy, and cost-effective alternative to typical electric and fuel-powered pump set. As a result, solar hopes to transform and create a cost-effective future for about 500 million small-scale farmers worldwide. However, the fundamental feature of a solar water pump efficiency is determined by three variables: pressure, flow, and input power. Access the total efficiency of a solar water pump to wired water efficiency is typically employed as the ratio between the hydraulic energy that comes out of the pipe and the energy that flow over the electrical wire through solar panel. The benefit of employing solar water pump is that they are dependable in rural and distant places. For example, in Africa, one of the world's poorest isolated location with a lot of water and the prevailing weather most days of the year. As a result, deploying solar water pump in Africa is the ideal alternative to any other fuel-based source and one that can stimulate life in all parts of the continent. Solar water pump has the potential to bring major environmental and socio-economic benefit both on the farm and the nation scale. Solar water pumping can aid in the stabilization, expansion, and diversification of agriculture production, which is also the cornerstone of the economy of the majority of African countries. As a result, while a solar water pump system has greater initial investment cost and it has minimal maintenance and operational costs. The objective: to analyze and design a control system via manual calculation, to verify with software application that achieve the complex engineering problem, to improve the knowledge of MATLAB software by applying numerical analysis, theory based of natural science, engineering knowledge, and engineering specialist knowledge. Scope: the work undertaken in this project is limited to the following aspect: the complete mathematical model of irrigation system, comparative study for the input voltage, motor current, proportional gain, and integral gain between the open loop system and closed loop system analysis. Simulation work using MATLAB Simulink as a platform.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arif Hakimi bin Nazaki. My metric number is CD20009. I will continue for the chapter 2, which is function of the component in the control system and open and closed loop system. First, we go for irrigation system. A solar generator power a centrifugal pump in irrigation system. A check valve is positioned at the suction pipe inlet that was introduced into the water tank. Water can only flow through the check valve in one direction. In this instance, the pump is being directed from the water tank. Water will be pumped into the pump through the input chute to prevent water from draining from the pump through the suction end of the pipeline. As we can see, there's a picture show of the irrigation system. Next is equation that related to irrigation system. First, pressure at the point just above the check valve, which is P above valve equal to P inlet pump plus rho GH. That was first equation. Next is pressure under the check valve equation, which is P under valve equal PA plus rho GD, which is equation 2. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yarjuna Rahmatullah bin Ghalibah. My matrix number is CD200003, and I'm from section 5, class of Control Engineering BDA30703. And today I want to present about the about today I want to present chapter 2 of our report, which is the types of control system. So firstly, there is a open loop control system. So this kind of system does not sense the actual output and does not compare the actual output to the desired input via feedback, and only manually altering the input can correct the output alterations. Despite being easy to build, stable, and affordable, these systems are incorrect and unreliable. Secondly is the closed loop system. So by incorporating a feedback, an open loop control system is transformed into a closed loop control system. Every time a system's controllable variable, which is output, is sensed, fed back on and compared to the desired input, an error signal is produced. The feedback control system considers the disruptions and takes the necessary corrective actions. These control systems are precise, reliable, and less noise sensitive. Closed-loop systems, however, are challenging to design for stability and provide oscillatory feedback. So the next part is about our project, which is the simulation model of the water pump controller. So the soft start and the PI pressure controller are implemented combined with the three-phase asynchronous pump motor to give regulated current motor start. To ensure optimal system operation, the PI pressure controller setting must be accurately determined. In order to ascertain these values, it should be essential to carry out some experiments to estimate the system transfer function using a simulation model with appropriately calibrated parameters to make the model act like the real system. So the MATLAB Simulink is used to carry out the simulation. The rectifier in a VSD and a solar generator are modeled as the optimal DC voltage sources.
Assalamualaikum, my name is Awangku Emrah bin Osman. My metric number is CD200-182. So for the chapter 3 is root locus, time and frequency response analysis. Transfer function. Applying the Laplace transform, the above modeling equation can be expressed in terms of the Laplace variable S. So you can see the equation. So we arrive the following open loop transfer function by eliminating I between the two above equation, where the rotational speed is considered the output and the armature voltage is considered the input. So the the question is here. So next you can see the block diagram related to the DC. This one, this one speed compressor, and this one. So root locus provide a powerful tool for selecting control system parameter that yield desirable transient performance. The root locus rule of construction show the effect of pulse, zeros, and gain change on the root loci. We can design control system from the root loci by selecting the best closed loop pulse and finding the related parameter. Therefore, open loop transfer function is this one. So you can see this one. And we're gonna plotting root locus for transfer function. We got angle, pole, zeros, and everything. So we plot the graph. So the left one is we using the paper graph, and the right one we use MATLAB software. So next one is plotting time response. Plotting time response, we use for transfer function, we do partial fraction and we get the equation as you can see here. And after that, use Laplace transform, and then like always we plot the graph. So we plot the curve using the paper, you will get the left one, and if you use the MATLAB, we get the right one. So the last one is to plot the plot graph. We use a MATLAB software. Then we get the graph as below. So we get this one, the last one. Okay, thank you. That's all from me. Thank you.
Hi, my name is Damal Aidil. My matrix number is CD200057. I'm going to present my part, which is chapter 4, the effect of P, PD, and PID controller. The effectiveness of the system and its ability to maintain and manage a desired water level in the tank were investigated using MATLAB simulation. It is simple to simulate the system and see the outcome for various value of KP, KI, and KD controller parameters since the PID controller is integrated into MATLAB. By adjusting the parameter up until the design criteria are satisfied, an ideal or acceptable result may be produced. We go next to 4.1, which is a proportional controller, P. Figure 4.1 show the system response with and without proportional controller. The performance without controller is very poor in terms of settling time, with very high steady state error and a final value 50% of the required reference target. It shows the requirement of controller to obtain the desired water or liquid level. The proportional controller reduce the rise time, improve the steady state error to some extent, but ringing and overshoot start to appear. A proportional controller with KP10 looks better in terms of reducing the steady state error compared with KP5. For KP10s, the settling time is about 2.95 seconds and overshoot of 47% and steady state value of 0.83. The high overshoot settling time and steady state error necessitate the requirement of integral and derivative part to be added in the controller, as not all of the design requirement can be met with a simple proportional controller. We go next to the next slide. 4.2 proportional derivative controller, PD, with KP10 and KD5. Figure 4.2 show the system step response using the PD controller. It's decreased overshoot and enhanced rise and settling time, but with a significant steady state error, the final number still falls short of the desired level. Next, we go to the 4.3 proportional internal derivative controller, which is PID. The proportional integral and derivative PID controller is depicted in figure 4.3.1 with KP12, KI15 and KD3 with an overshoot of less than 5%, a settling time of less than 2 seconds and a steady state value of 1, which correspond to the required water level specification. The initial design specification are met in this case. The rise time is also shortened. In this instance, as a result, the desired design target is set with a PID controller. Additionally, as shown in figure 4.3.2, the overshoot can be decreased for the PID controller with KP9, KI50 and KD2 at the expense of slightly increase in the settling time. Lastly, we're going to 4.4, comparison of PD controller. In order to better visualize their performance and demonstrate the PID controller superior performance when compared to the others, all the controllers are plotted on the one graph in figure 4.4. You can see here, the water level may be continuously controlled with such PID control system without the need for human operation, saving time and manpower through automation. The PID controller led to the system automatically stabilize it close to the desired set point. That's all for my part. Thank you.
In Chapter 5, Conclusion and Recommendation. In conclusion, the project objectives were met with success. First, we can use relevant methods from Chapter 2 and Chapter 3 to analyze the capability, steady state errors, and strengthen responsiveness of the control system. Following that, we illustrate, analyze, and create local system utilizing simulation using MATLAB software, and we managed to validate the concept. The MATLAB program is an interactive system that is used for block diagram modeling and simulation. Aside from that, we can address a different problem with suitable coding, but it may be easier if it does more practice with the software. We may also plot a graph based on the data acquired using the software. In this project, for example, we may plot the root locus graph with damping ratio, transfer function, and natural frequency values. Furthermore, as a result of working on this project, my individual and collaborative skill have increased. What matters is that we can execute problem-solving approach and verify the principle present in fundamental control system via manual computation and simulation in computer-aided software in a group project. Recommendation: first, provide simulation training in computer software to student to make student be master using simulation software such as Simulink or MATLAB. Brief student clearly regarding of the project assignment. Recommend for future research to study about root locus, time and frequency response analysis. And lastly, provide example of working step. Thank you.